Today you're going to be looking at systems, and we're going to be looking at solving systems by graphing and analyzing special systems, solving systems of equations by substitution, solving systems of equations by adding to eliminate a variable or elimination, and then we're going to talk about the best way to solve for systems. We have previously reviewed systems with the 4 steps of elimination, and then before that we did the substitution. Looking at your notes and looking at the project, most of you have completed the project. We just need a little bit more brushing up. So we're going to go ahead and go back to systems and refresh our memories. So let's start off with the definition of systems. This is A, solving systems by graphing. Systems of linear equations. That is 2 or more linear equations with the same solution. 2 or more linear equations with the same solution. Next, it asks for the definition of a system of linear equations. So, a system, you know what a line is. An example of that would be y equals mx plus b. Excuse me. And so you have now the solution of a system of linear equations, which is any ordered pair that makes all of the equations in a system true. Okay, so that means that if you have 2 equations in a system, the ordered pair, which is the point of intersection, would be true for both of those equations. So let's look at example 1. Checking a solution to a system of linear equations. The directions state if the given ordered pair of a solution. Example 1, checking a solution to a system of linear equations. Is the given ordered pair a solution in the given system of linear equations? That's a lot of words. So let's look at equation A. I have ordered pair 3, 5, and then I have equation 2x minus y equals 1. The second equation is x equals negative 3y plus 11. So what we're going to do here is we're going to substitute the 3 and the 5 for x and y. In the first equation, I'm going to say 2 times 3 minus 5 equals 1. We want to prove these as true or false. They have to be true for both equations, or for however many equations you were given. So let's look at A first. So that's 2 times 3 minus 5 equals 1. 6 minus 5 equals 1. 1 equals 1. This is true. For the second equation, that's equation A, this is equation B. This is equation A. For equation B, 3 equals negative 3 times 5 plus 11. 3 equals negative 15 plus 11. 3 equals negative 4 The left hand and the right hand side of an equation must be equal for the system to be true or for the equation to be true. In this case, the first one was true and this one is false. So, the question states, is a given ordered pair a solution to the given systems of linear equations? In this first case, the answer is no. Let's go on to B. Order pair 1, -5. The first equation is A, the second equation is B. 2x plus 3y equals -13. Substitute the 1 and the 5 for the x and y, so that's going to be 2 times 1 plus 3 times -5 equals -13. 2 times 1 is 2, plus 3 times -5 equals -15, still equal to -13. Combine like terms, 2 plus -5 is -13, equals -13, and that is true. And that's for equation A. Now let's look at equation B. Equation B is going to be y equals x minus 6. Y is -5 equals 1 minus 6. -5 equals 1 minus 6 is -5. The left hand equals the right hand side, so this is true. So the solution to this is yes. Those are your first examples. Okay, now it's your turn. We're going to do this one together. Let's do this one together. It says, is the given ordered pair a solution to the given system of linear equations? Just like our examples, but with new equations and a new ordered pair. In this problem, we have the ordered pair, -1, 3. Equation A is 3x plus 2y equals 3. Equation B is y equals 3y minus 10. Let's just go straight into substitution with equation A. 3 minus 1 plus 2 times 3 equals 3. 3 times -1 is -3. 2 times 3 is 6. Remember, we're completing the order of operations. Every new line is a new equation. Equals 3. That doesn't change because that was given. 3 equals 3. This is true. Looking at equation B, let's go straight into substitution. It's x equals 3y minus 10. X will be -1 equals 3 times 3 minus 10. That 3 is the y. Collecting like terms, -1 equals, let's work on the right hand side. 3 times 3 is 9 minus 10. -1 equals 9 minus 10, which is -1. The left equals the right. This is true. So yes, this is a solution. Okay, so let's talk about what we've gone over. So steps of solving a system of linear equations by graphing. We have to graph, or we will graph the first line. The second step will graph the second line, and the last will be a solution finding the solution at intersection. Okay, that's where the lines cross. Remember, we have different types of lines that we've been talking about: parallel, perpendicular, and particular. The intersections will look different if it's perpendicular compared to different intersections. That's going to be based on slope. So let's go ahead and go from there.